Hi everyone and welcome to Lab 6. In this lab, we are going to study the process construct in VHDL. This is a very useful construct. You might recall that we had briefly mentioned this process construct in the past when I said that in VHDL, all of the statements are concurrent except those which occur within the process block. So the statements which are inside the process block are sequential statements. Today we are going to see exactly what is the purpose of this process construct, how to use it effectively, and what are the type of sequential statements that we can put inside the process block. Okay. And the exercise for the lab today is going to be on designing a priority encoder using the process construct. So we will also see what is a priority encoder and so on. So let's get started. So far we have studied a number of interesting constructs in the VHDL language. Okay, let's do a quick top-down recap of what are the constructs of VHDL that we have studied so far. Okay, and where does the process construct fit in? So in a VHDL file, there can be multiple design units. And so far we have seen two types of design units. One is an entity block and the other one is an architecture block. Each of this is like an independent block, right? It has a name and it has a begin end sort of thing. It's a block. So in a single file you can have multiple entities and architecture blocks. There are two other kinds of design blocks in VHDL called packages and configurations. These are optional in a VHDL file. Okay, and we will not be seeing them in detail in this course, but you are encouraged to look them up. A package is kind of like imagine a module in Python or like a library. A package is a collection of useful things all put in one place that you can reuse later. For example, if you are writing structural descriptions and you are frequently using two input AND gate or gate and so on, why not put them all in one place? Okay, why not define those entities and architectures in one place and then just say use that package? Okay, so let's say you put all your useful things in one file, okay, then call that a package, and then you can include that in your designs. So this is the idea of a package. You package the useful things together and reuse them. Okay, have you already used a package? Yes, we have used some IEEE. We have used some packages which are in the IEEE library. Okay, like 1164.all. We have used this package in the past, but these are standard library packages. The user can create their own. The second is configuration. Okay, configuration is a way of binding together a component and an architecture. Remember, a single entity could have multiple architectures, right? Let's say A1, behave, struct, and so on. There could be multiple architectures for the same entity. Now when I create an object of this, let's say E1, which architecture should be used? You can either specify that when instantiating this object. For example, when I say create an object called E1 of type entity name, and then I can specify which architecture to be used. So let's say struct, and then there is a port map statement and so on. So this is a syntax for instantiating an object of this type, and at that time I can specify which architecture should be used. Another way to do that in a more flexible manner is called configurations. Okay, so both of these things are useful to a designer, to a professional designer, but at the student level they may not be very useful at this point of time, so we will not see them in detail, but I'd encourage you to look them up. So let's take our attention back to entities and architecture. Okay, so the general form of an entity declaration is this. There is an entity, it has a name, end entity, And there are two parts. It can have port declarations. Basically, what are the input ports, output ports, what are the types, and what are their modes. And we have these generic parameters. Recall that you can have a parameter like n of type integer, which is the size of the input port or something like that. You have these generic parameters. You may have this. This is both are optional. Okay. Now the architecture design unit can have these two parts. The first part, before the begin keyword, are all the declarations. And after the begin keyword up to the end are a set of concurrent statements separated by semicolons. Okay. So what are the declarations? Like when you want to use a component, you declare it here, or you declare signals. You can also initialize signals using something like this. Okay. So all the declarations and their initialization can go here. Okay. And then we have a set of concurrent statements. All of these statements are concurrent. That means there is no order. It does not matter if you write this one first and this one second or this one first. You have to interpret them as being concurrent. They all exist at the same time, or they describe hardware. Each statement describes some hardware that exists at the same time. Okay. So they have no priority or ordering or anything like that. They are all concurrent. Now, what are the types of concurrent statements that we have seen so far? The first one we saw is component instantiation. So in this part, you declare a component. Let's say you are using a 2-input AND gate, you declare it here, and then you create an instance of it here. That statement, for example, component name A1 is an instance of AND gate, and then you port map the first port to A, second port to B, and so on. This is a component instantiation statement, and it is also a concurrent statement. Okay. So in the sense, what have we done is we have created a component called A1, which is an AND gate. And if we have other statements here, they exist simultaneously. Let's say we have another statement which is some other gate. They all are concurrent. Then we saw signal assignment statement. Okay, so instead of actually using components, you could do things like A is assigned B or C and not D. You could do something like this directly instead of using these basic operators. We could use gates and write a statement using components. If you directly use these operators, you can have a simple signal assignment statement like this. Now we saw if you want to do some more complicated things, we can use some if or when or select keywords in the signal assignment statements to make conditional signal assignment statement, which looks like this. A is assigned some value when some condition, else some other value when some other condition, else, and so on. And we also saw selected signal assignment. Okay, so based on the value of some other signal, you could choose one of the few cases. So with S, select, okay, A is assigned 1 when S is 0, 0, it's assigned 0 when S is 0, 1, and so on, something like this. So these are essentially very similar, and we saw an example of how to write a MUX, a multiplexer description, using all of these ways. These are different ways of achieving the same thing, and a designer would use whichever is more convenient to them. Okay, whichever is more convenient, or whichever is more efficient, or whichever is more intuitive, more natural. Then we saw this very useful statement called a generate block. What is it? It is essentially a way of putting some of these statements inside a loop. So for example, if you want to instantiate an array of 100 AND gates, instead of writing them down like this, A1, A2, A3, and so on up to A99, A100, you could just have a loop and create a component AN, for example. So this is possible using generate block. So essentially it's nothing new. It is just a way of putting these things in a loop, and when the VHDL file is interpreted, the first thing that is done is that this loop is expanded out. Okay, so if there is a loop from 1 to 10, then actually it is just replicated 10 times. So it would just appear as if it just has concurrent statements, right? So generate block just allows us to conveniently express regular structures using some loops. So essentially these are all concurrent statements we have seen so far in the previous labs. Now we are going to see a very interesting concurrent statement called a process block, which is very useful. So what is the purpose of the process block? What does it do? And so on. So that's what we are going to see now.